Hello, in this video we will talk about hypergeometric distribution and show examples of using hypergeometric random variable. So hypergeometric distribution is connected with selecting items from a population, and we will check the number of positive. So because in a population we define there are two kinds of items. For example, we have total n plus m batteries. So here we define n are acceptable quality and m are not acceptable, or we say defective. So this is a binary. This is like a binary case. So now we choose n with a small capital number, small alphabet. So n number is less than n and m. So we choose n randomly from this population, and we'll check how many the number from this n are positive or the acceptable quality. Then this number's probability are following so-called hypergeometric distribution, or this number a random number from hypergeometric distribution. So we use the probability formula to calculate the probability of x equals I. So I will represent the number of acceptable from this capitalized N. So this expression is the division. Division in denominator is the total combination from n plus m, then select small n. So this is the combination. And the combination, combination is the factorial of this one divided by the factorial of this one, then divided by the factorial of this one minus this one, right? And in the numerator, the two parts, multiplication, they are also combination. So the first combination is from n select I. So n here positive or acceptable, select a number I. Then next combination is m select a number of n minus I. So this multiplication is a total combination of selection positive from n, right? Then this division is the probability for selecting the number positive equals I. So I can be 0, 1, 2, minimum of n and n. And its expectation of this positive number equals n times n divided by n plus m. And you can see if we just see the part of n divided by n plus m, then we can say this is the p. This is quite similar as the binomial distribution, because binomial distribution is also np. But binomial distribution, we say has a constant positive rate, because this no matter what's the first one you selected is positive or negative, the constant is correct, is the same for the next selection. But hypergeometric, the probability of selecting a positive, negative will be changed, but the expectation is the same. Then the variance of this hypergeometric random number is np times 1 plus p. You can see this is the binomial random variables variance, right? Then here we'll times a factor, and this factor is 1 minus this division. And actually, if the n is very small compared with n plus m, then this part will be 0, and the hypergeometric random variable can be approximated with a binomial random variable. Then we take a look at an example. Components of a 6 component system are to be randomly chosen from a bin of 20 used components. So we select 6 components from 20. And the resulting system will be functional if at least 4 of its 6 components are in working condition. And if 15 of the 20 components in the bin are in working condition, so what is the probability that the resulting system will be functional? So this is the case of hypergeometric, because we just select 6 from total 20, and for of these total 20, there are 15 are functional and other 5 are not functional. And for these selected 6 components, we want to have functional at least 4, right? So this is the hypergeometric random variable for this x. So this x is the functional number we are interested in from total 6 components selected. So we use x as geometric random variable with the parameter 15, 5, 6. So 15 is total functional parts from the population. 5 is the total unfunctional defect parts from population. And 6 is the number we chosen from the population. So the probability that the 6 system will be functional is p x larger than or equal to 4, right? For this hypergeometric random variable. So we just add from 4 to 6 for this probability. Then denominator is the same with a combination of 20, select 6 item. Then numerator is 3 parts. Each part is the production of 2 combination. So 15, 4, then 5, 2. Or 15, 5, then 5, 1. Or 15, 6, then 5, 0. And so the resulting probability is about 0.8687. So it's quite high, right? Because the expectation probability is quite high. Because 15 of 20 is about 0.75. So the expectation is 0.75 for this hypergeometric random variable. So this functional number probability is about 0.75. If we times 6, so about 4.5 is this expectation number, right? Thanks for watching.